We're going to have a review of the index laws in this session. So let's start off. It is very interesting and it all makes sense. We've got 2 times 2 times 2. What's that equal to? That's called 2 to the power 3, or 2 cubed. It means 2 multiplied by itself 3 times. That's a short, convenient form, and it's actually called index form. Okay, so we have 2 to the 3, where this is the base, and this little beastie here is called the index. It's also called the exponent or the power, but the index will do us for now. Okay, and that's it. 2 to the 3, 2 to the power 3, and it definitely does not mean 2 times 3. So please don't make that mistake. That is not true. Okay. Now, performing mathematical operations on numbers, or pronumerals for that matter, which are written in index form, requires us to use the index laws. Here they come. The first index law, ladies and gentlemen, says that a to the m times a to the n equals a to the m plus n. Now that all looks very abstract, so let me explain first that the bases must be the same to allow us to use this law. Let's do a little example here. So 2 to the 3 times 2 to the 4, according to the index law, would be 2 to the 3 plus 4, which would be 2 to the 7. That's how it works. Now, proving this the long way, without the index laws, guys, it makes perfect sense, because 2 to the 3 is 2 times 2 times 2, is it not? And if we multiply that by 2 to the 4, which is 2 times 2 times 2 times 2, you tell me how many 2's are there in there. There's exactly 7 of them, so the answer has to be 2 to the 7. That's why this law makes so much sense if you think about it and you check it the long way. Okay. Number 2, index law number 2, that says that a to the m over a to the n, that's equal to a to the m minus n. Again, the bases have to be the same to allow us to use this law. Here's an example for you. 3 to the 6 over 3 to the 2. Now, by this index law, that will equal 3 to the 6 minus 2, which is 3 to the 4. Here comes our long way check on that, okay? So if we had 3 to the 6 over 3 to the 2, you know that you can cancel a 3 here with a 3 there. That's 3 to the 6, that's 3 to the 2. Now let's do those cancellings. There's the first lot and there's another lot there. So now we've just got 1 left on the denominator and we've got 4 of these left on the numerator, so the answer is going to be 3 to the 4, just as we found up here. See, it makes perfect sense, guys. Now here's an example for us to do. Simplify each of the following, so let's go for that. Now number A, what have we got here? M to the 4 n cubed p times m squared n to the 5p cubed. Okay, I've just put some multiplication signs in the middle here to break it up a bit so we can see what we're doing, okay? Because all these terms here are multiplied. These pronumerals are all multiplied by each other, okay? The m to the 4 is multiplied by the n cubed, which is multiplied by the p to the 1. By the way, there's a 1 there if it's not stated up here. And away we go. Now we have to look for the things that have the same base and use that index law. So we can say that's m to the, what is it? That's right, it's m to the 4 plus 2 times n to the, have a look, 3 plus 5 times p to the, how many? 1 plus 3. Okay, now let's simplify that. It's m to the 6 times n to the 8 times p to the 4, and we can dispense with the multiplication signs now that we're on safe ground here, and put a box around it, and Bob's your uncle. We've done it, guys. See? No problem. B now, what do we got? We've got 2a squared b cubed times 3ab to the 4. Okay, so let's do the actual numbers first. So that's going to be 2 times 3 times. Now, a to the, what do you think? A to the 2 plus 1, because there's a 1 implied here. although not stated, it is a to the 1, okay? And we've got b to the 3 plus 4, haven't we? Yes. Simplifying that, that's going to be 6a cubed times b to the 7. Now we can dispense with the multiplication signs. And we've got 6a cubed b to the 7. Yes? Simple as, guys. Now, let's do number C. That's index law number 2 at work, that one. So let's have a good look at that little beast. We've got that thing. Goodness gracious. Well, this is going to cancel into that 5 times because 2 into 10 goes 5, so let's do that first. Okay, that's got that one sorted out. Now we can deal with the rest of it. So I've put the 5 there on the denominator where it belongs, and we've got x to the 5 minus 2 because of this 2 down here on the denominator, and y to the 4 minus 3. Okay, so can you see that okay? Do you get it? Okay, so let's simplify that. That's going to be x to the 3 times y to the 1 over 5, and now we can just not bother with the y to the 1. We know it's going to be x cubed y over 5 and put a box around it, and Bob's your uncle. We've done it, guys. How do you like it? It's mighty fine. That's what it is. If you're not sure, guys, always do it the long way without the index laws, just to check up on yourself. You'll find it works just fine and dandy. Third index law coming up. This one is an interesting one. This is that anything to the 0 equals 1. That is, accepting 0 itself. So, for example, 2 to the 0 would equal 1. 3 to the 0 would equal 1. Okay? 1 to the 0 even equals 1. Alright? So, we can show actually that this is true by using the second index law, in case you're interested. So I'll show you. Now we know that by the second index law, guys, 2 to the 3 over 2 to the 3 would equal 2 to the 3 minus 3. And 3 minus 3, of course, is 0. So that would be 2 to the 0, would it not, according to the second index law. Now, let's do it another way. We know that 2 to the 3 over 2 to the 3 is equal to 2 times 2 times 2 over 2 times 2 times 2. Now we can do cancellation throughout the nation. That one, and that one, and that one. And we're just left with 1 over 1, which is 1. But, guys, this and this are equivalent calculations which have to give the same answer. So we got that answer this way of doing it with the second index law. We got this answer doing it the long way without the index laws, and they must be the same thing. So therefore 2 to the 0 must equal 1. Yes? Terrific. Okay, simplification. Simplify each of the following. Okay, so there's A. We've got that thing there. Now you know the answer, don't you? What is anything to the 0? Well, it equals 1, guys. It's as simple as that. Okay, it doesn't matter what's in the bracket. If it's all to the power 0, the answer is 1. Okay. B. What's that thing? Goodness. Well, I've just put a little multiplication symbol in there just to show you that that first thing is multiplied by the thing in the bracket to the 0. So the thing in the bracket to the 0, you know what that comes to, don't you? Yes, it equals 1. So we've got minus 4 times 1, which, as you know, is minus 4, and that's the answer. Okay? No problem, guys. Fourth index law, 3 down, 3 to go. Fourth index law says that a to the m, all raised to the power n, gets us, what do you think? It gets us a to the m times n. Now this can be shown using the long way, and I'll show you. So if you had 2 cubed, all cubed, according to this fourth index law, that would be 2 to the 3 times 3, and you know that 3 times 3 is 9, so that would be 2 to the 9, okay? Now let's do it the long way. You've got 2 cubed, all cubed, which would be this thing in the bracket multiplied by itself 3 times, okay? You got that. Okay, now let's see what that comes to. Well, that's 3 of them, this beastie, times this one, which is that, times this one, which is that, and you have a look. How many 2's have I got there, guys? How many? We've got 9, so the answer is 2 to the 9. Now these calculations are equivalent. This is using the index law, the fourth index law. This is doing it the long way. Therefore, the answers must be equivalent, which they are, and therefore this rule must apply, okay? This rule must apply. So therefore, that's the fourth index law. Fifth index law goes like this. A times B in brackets all to the m gets you A to the m times B to the m, where there's no bracket anymore, okay? So let's have a look at this. We could show this as follows. Have a look at that. 2 times 3 in bracket all to the 4, okay? So that would be, according to this fifth index law, that would be 2 to the 4 times 3 to the 4. Yes? Alright, now just hang on to that for a minute and we're going to do it another way. 2 times 3 in brackets all to the 4. With actual numbers here we can work this out because 2 times 3 is 6. So that must be the same as 6 to the 4. Now let's work out this one and work out this one to see whether they're equivalent, alright? So that's 16, which is what 2 to the 4 is, 2 times 2 times 2 times 2, times 81, which is 3 to the 4, okay? So that's, if we work that out, you'll get 1296 with your trusty calculator, or if you do it long multiplication, you'll get the same. And 6 to the 4, ladies and gentlemen, is the same thing. They're the same answer. So you can see that this index law works just fine. Okay? Happy? So now we come to the sixth and final index law. And this one states that A over B, all raised to the power m, is equal to A to the m over B to the m. And we can show this as follows. Say, for example, we had 6 divided by 2, all raised to the power 3, ladies and gentlemen. Now, according to this sixth index law, that would be 6 to the 3 over 2 to the 3. Yes? But of course we know that this thing inside the bracket here, because we've got two actual numbers, we can work this out. This comes to 3. 6 over 2 is 3. So it's 3 to the power 3, which is 3 times 3 times 3, which comes to 27. Now, what's this beastie up here? Hopefully that's also 27. Otherwise we might be in a spot of bother. So this is 6 cubed, which is 216 over 2 cubed, which is 2 times 2 times 2, which is 8. Now 8 goes into 216 exactly, wouldn't you know it, 27 times. So it's the same, which was what we were expecting, so this index law is working just fine. Okay? Alright, so we've done 6 index laws, and now we're going to do a little bit of practice before we wrap it up, alright? Let's go for A. Now we've got 2 times n to the 4 in brackets, all raised to the power 3. Now according to one of those laws, that's 2 cubed times n to the 4 cubed. I thought, yes, that's the fifth index law. I'm losing track of them. That's which one it is in case you're interested, okay? Alright, that's the one that said that A times B in brackets all to the m would be A to the m times B to the m, I think. So, now what are we going to do now, guys? We've got to simplify that a little bit more. So, we know what this comes to. That's 2 times 2 times 2 because that's an actual number. That's going to be 8, isn't it? Now, this is going to be n to the 4 times 3, which gets us n to the 12. So it's 8. Yes, that's the fourth index law that we've just used to expand that out there. And what are we going to get? 8 times n to the 12, and that's the answer, guys. Dispensing with the multiplication sign, put a box around it, and we've done it. Okay, so that's A done and dusted. B, similar. Okay, so let's go for that. You should be getting a little bit more used to this now. So what are we going to do with that, guys? We're going to call that 3 cubed times A squared cubed times B to the 7 cubed. All right. Now that was the fifth index law. That's going to get us 27 times A to the 2 times 3 times B to the 7 times 3, which if we then simplify on the next line, we get 27 times A to the 6 times B to the 21, and dispensing with the multiplication signs, you get that, and Bob's your uncle again. Good old Uncle Bob. C, let's go for that one. Okay, what do we got? A very nice little problem. So let's simplify that just bit by bit, line by line. That's the way you do these things. You don't get overwhelmed with them because they can get pretty complicated. So we've got the top line raised to the power 4, that's the numerator raised to the power 4 over the denominator raised to the power 4. Now let's simplify that further. That's the sixth index law, in case you're interested, and that comes to 2 to the 4 times x cubed to the 4 over y to the 4 times 4. Okay? Yes? Alright, they're the index laws. Now, what are we going to do with that, guys? I think we're going to multiply this 3 by 4, call that one 16, and call that one 16. I think we're pretty well done. Dispensing with the multiplication signs now, we've got 16x to the 12 over y to the 16, and Bob's your uncle again. Isn't that great? Alright, now, D. What was that one? Minus 4 cubed. Now, you've got to be a bit careful with these ones. What it is actually minus 1 times 4. All raised to the power 3, guys. So, okay, I've got minus 4 multiplied by itself 3 times. Now, the only problem we've got here is with those signs, okay? So, let me call it minus 1 times minus 1 times minus 1 times 4 times 4 times 4, okay? Now, we can see what to do with that. The minus 1 times minus 1, the first two of them will get you plus 1, which if you then multiply by another minus 1, you'll get negative 1, okay? To make this all a bit simpler, if you have an odd number of these minus 1s, the answer will be minus. If you have an even number of them, the answer will be plus, alright? Times 4 cubed, and 4 cubed, if you care to work it out, will be 64, so the answer is minus 64. And we're at the end, guys. Thank goodness for that, some of you are saying. So we've got this remember thing. To simplify expressions with constants and or pronumerals in index form, the following index laws are used. There's law number 1, there's number 2, and there's number 3. This one was 4, that one was 5, that one was 6, okay? So now what you've got to do is go and do plenty of practice so you get good at this stuff. And practice makes perfect. Believe me, with these index laws, practice makes perfect. So please do plenty and you'll become perfect, alright? And we'll see you next time. All the best.